Hello, I'm Nick Bergeron, and today I'm going to be going over my lab report for A2610 Lab 1 digital sampling. So just some quick background for the lab. Many experiments involve measuring values over a length of time, and this lab is, of course, one of those. In this lab, we did a frequency analysis of time-varying signals, and these time-varying signals can be described as a general function or waveform. In some parts of this lab, we had to identify several different types of waveforms, such as sine waves, square waves, triangle waves, and a few more. But only the different characteristics of sine waves were calculated. And for my personal experiment, I measured the change in power of a sine wave as distance from the waveform emitter increased, but I'll touch more on that later in this presentation. So to implement said lab, it was performed using a MIDAC and several accessories. Those accessories were a audio jack and a microphone. So to hook up said MIDAC, I used both my personal laptop, but then I had to switch to my PC after I had after my laptop ran into some issues. And the MIDAC was used to measure the frequencies of waveforms of various signals using both the audio jack and the microphone. But for my experiment, I only used the microphone, which I guess I'll go into a bit more depth on mine right now. So essentially, using the same frequency, I measured distance, using the same frequency, I increased distance between the speaker and the microphone to measure the decrease in power as distance increases. So here are some results from the lab. On the left is we have the chart of relative response versus frequency. So essentially, what this is we have I played different sounds at different frequencies, and I got the outputs both using the audio jack and the microphone, and then I plotted that difference on this graph right here. And the formula was the power of the microphone over the power of the audio jack. So as you can see, the microphone picked up a lot more the microphone picked up a higher magnitude at the same frequency. But what's interesting here is that as initially as frequency increases, so does the power picked up. Which at first this to be really to make a whole lot of sense. But now that I thought about it, just like our ears, a microphone has a certain frequency of sounds that it's going to pick up best. So as we can see right here in the 100 to 200 range, it's a bit lower. Of course, I think that this right here is an anomaly caused by I guess just microphone issues. I don't think that this is really around like the 1000 range or the 1000 hertz range. I don't think that that's really indicative of the graph as a whole. But initially, as frequency increased and the microphone could actually pick up the signal better, then the power or the transmitted power to the microphone also increased. But then at around the 8000 hertz mark, as the sound becomes too high pitched for the microphone to hear, then it slowly starts to drop off over time. Oh, sorry. And then here is my experiment, which is power versus distance. As you can see, I increased the distance, and I plotted the power. Actually, I was actually kind of shocked by these because it seems to follow a roughly linear path, but I thought that it would actually be cubed just because I know that electricity drops off with 1 over the square root, and I expected frequency to be the same, but apparently not. So yeah, here are some conclusions from the lab. I think, like I said earlier, the disparities in that just right here in the graph was due to microphone issues. But like I said, uh, initially relative frequency increased with frequency, but just because as the frequency became too high for the microphone to pick up, it then began to decrease. And then also power decreases at a roughly linear scale with distance for frequency. So, like every lab, proper use of the equipment is important. So these next few labs of the class, as our results become more and more important, and as we have more in-depth lab reports, I'll definitely need to be careful of proper usage of the equipment going forward.